we have linear and we have rotational. What we're going to do is we're going to just kind of make a table of the items that are linear and the rotational equivalent. For example, x. What's the rotational equivalent of x? Linear position, Travis.
Arc length?
I'm sorry, say again?
Is it arc length?
It's not arc length. Actually, the rotational equivalent won't quite be arc length. Emma.
Theta.
Theta. Okay. The linear equivalent of linear velocity is what, Sarah Jane?
Omega.
Omega, angular velocity. The linear version is acceleration. What is the angular version, Bohit?
Fish.
Nice. That was impressive. We have the linear version is UAM. What is the rotational version, Henry?
Do you want me to say the big thing or just
Whichever.
uniformly angularly accelerated motion?
Otherwise lovingly called UFISHY-M, which is easier to say, but uniformly angularly accelerated motion is correct as well. We have the term mass is the linear version. What is the rotational version, Mr. P? It's okay. Henry was here last time. Henry?
Moment of inertia.
Nice. We have the moment of inertia is rotational mass. We have the linear version is kinetic energy, 1/2 mv squared. What is the rotational version? In other words, what is rotational kinetic energy, Zach? It's okay, you're not seeing it, help them out. What's the rotational version here of kinetic energy, Catherine?
1/2 the moment of inertia times angular velocity.
Notice it just uses the things above it. 1/2 mv squared rather than mass and velocity, we have moment of inertia and angular velocity. So rate rotational kinetic energy. Okay, there really is no linear version of, but I just want to put down torque equals RF sine theta on here, even though there's really no linear version of it. But we also have the linear form would be net force equals mass times acceleration. John, what's the rotational equivalent of that?
Some of the torque equals inertia times omega. No.
Careful, you called it inertia. It's the moment of inertia. You got to be careful. I know it seems a little bit long, but it is the moment of inertia. Good. We have power equals force dot product with velocity. What is the angular or rotational version of power? We haven't gone through it yet, but you should be able to see it from the stuff on the board. City?
Torque dot omega.
Torque dot omega, right? Just putting in the rotational equivalent. And we've done all those. Good. Just to give a good relationship here, it helps ground you with when it comes to the rotational stuff.